Alright, today we are solving cubic inequalities. This is what it says up there, and that's what we're doing. So if we're going to write a question out, it'll be written in its full mathematical way. It will be written like this. So find the set of x where, in this case, the example I'm going to do is x cubed, not x squared. X cubed plus 2x squared minus x minus 2, and I want to know where that is less than or equal to 0. So basically what it's saying is what x values make this less than or equal to 0. Alright, now textbook, in the textbook they haven't, in the example that you're doing the questions, they haven't actually written it like that, but anyway, not to worry. So what have we got to do? So how we can do that is we can use our cubic graphs. So if I say, all right, let's make y equal x cubed plus 2x squared minus x minus 2, and let's graph that, and we're going to then our graph will be able to help us. All right, so let's try, say, well, actually, rather than me use calling that y, let's call it p of x. All right, so if you like, y equals p of x. So if I do p of 1, for example, I'll get 1 cubed plus 2 times 1 squared minus 1 minus 2. So that's 1 plus 2 minus 1 minus 2, which is 0. So we know that x, whoops, I don't need that bracket in this case. So that means that x take 1 is a factor. Alright, so we now got to divide x take 1 into this, and previous lessons I've been just using the synthetic division. So I know some people use the long division, so I'll do the long division method this time. So we've got x cubed plus 2x squared minus x minus 2. So to get x cubed, you've got to multiply x by x squared. And so then multiplying x squared into that, x cubed minus x squared. And then we've got to take those things away. X cubed take x cubed 0. 2x squared take plus, so that's 3x squared. So minus x and the minus 2 bring them down because we still got them. Alright, so what else have we got? To get 3x squared, I'd have to multiply that by x by 3x. 3x times x is 3x squared. 3x times negative 1 is negative 3x. And then I've got to take them away. Alright, so 3x squared take 3x squared, 0, negative, negative, it's plus, so negative x plus 3x is 2x, and then the 2 bring it down. Okay, so to get 2x, we've got to go x times 2. So 2 times x is 2x, 2 times, whoops, that should be negative 2, not negative 1. And 2 times negative 1. And then when we take those away, we get 0. So what do we got then? We've now got that our y, or our p of x, is x minus 1 times x squared plus 3x plus 2. Now, x squared plus 3, plus 3x plus 2, two numbers that multiply to give us 2 and add to give us 3. Well, there's only 1 and 2. All right, so that's what the factorised form of this would look like. All right. So now what I'm going to do is I'm going to sketch a graph, and I don't need a real fancy one. All right, all I really need is a rough sketch. We're just going to use the rough sketch, and then we're going to have a look. So if we want our x-intercepts, I mean, you know this, all of this so far, you know all of this stuff. All right, so x-intercept y equals 0. So 0 equals x take 1 times x plus 1 times x plus 2. And so the null factor law says x minus 1 is 0, or x plus 1 is 0, or x plus 2 is 0. And so what we get when we rearrange, add 1 here, you get x equals 1. Take 1 here, you get x equals minus 1. Take 2 here, you get x equals minus 2. So what that then we can do is we can do, like as I said, a rough sketch. And what we know about our rough sketch here, probably didn't need to go that far over here. So there's our x, here's our y. Now there's 1, -1, -2, and we know that it goes through these. All right, we could get our y-intercept. So we're having a look at our y-intercept is when x equals 0. All right, and if we put x equals 0 into this here, you get -2. All right, I'll just do that. All right, so here we've got this 0 cubed, 2 times 0 squared, minus 0, minus 2. So all of these are all 0, just got minus 2. So our y-intercept, and our y-intercept, when x equals 0, it's -2. So that's down here. All right, so we've got to go through all of those. Now, when we have a look, it's cubic, and it's a positive cubic, so all positive cubics start at the bottom left, finish the top right. So the only way we can go through this is this has got to go up here, down here, it goes around through here, and it goes up there. All right. So let us now get to what the question was about in the first place. Let's get rid of all that stuff. So the question in the first place asked us to find, oops, I haven't written that properly, x cubed, where are we, plus 2x squared minus x minus 2, plus 2x squared minus x minus 2, where that was less than or equal to 0. And remember I said let's make y equal that stuff. So if I've made y equal all of that, then in here I could replace this with y. And if I did that, what we're looking at then is for the graph, so remember this graph here is the y equal. we're looking for where y is less than or equal to 0. Now, y is less than or equal to 0 down here underneath the x-axis. So we're interested in the x values where this graph is below the axis. So the graph being below the axis, let me change my colour, and I'm going to highlight it in red. So the graph is below the axis here, and it's equal to 0. So equal to 0 is on the x-axis there, and then here, and around to there. Now the question wants us to say what x values correspond to what I've just done there in red. Oops. And the x values that correspond to that are these ones and these ones. There and there and down here. So how do we write that? Running out of room here. How do we write that? Well, there's two parts. So this bit down here, that bit down here goes from negative infinity up to negative 2. And because it's equals to here, we have the union with, because there's 2 bits, starts here at negative 1. And again, because it's equals, we use a square bracket, negative 1. And we stop at 1, and 1's included. All right, so that's how you would write it in interval notation. In set notation, it would be written in this way: x such that x is less than or equal to negative 2, the union with x such that x is between negative 1 and 1. All right. That's about all we need to know. There's a little technicality which I won't worry about. I'll point that out to you next year. But at the moment, if you can, go through that process. So just a rough sketch like that is all we need, because with these we're going to be looking at whether the thing's above the axis, below the axis, on the axis. And so you just need a rough sketch to visualize where that is. All right, as always, have fun, and if you need help, get back to me.